So, hello guys, good. So let's quickly treat Chem 101 integrated rate law. Integrated rate law. I believe at the end of the video you are going to understand. And don't forget to subscribe to the channel, drop a comment, and like the video. Now, let's start with zero order reaction. Zero order, zero order reaction. So, we have this is the formula. We have AT equals to minus KT plus A naught. This is the concentration at time t. This k, this k is the rate constant. This k is the rate constant. This is time, and this is the initial concentration. Initial concentration, concentration at time t, the rate constant, and the time. Now we can liken this to the normal equation of a straight line that we know, y equals to mx plus c. So where we can liken at as y, minus k as m, minus k as m, y ao as what, as c. Sorry for okay. Yeah, so at can be y, assuming you are plotting a graph for this. On the y-axis you plot your at, on the x-axis you plot your time. So your slope will be minus k, your slope will be your minus k, while your intercept will be your initial concentration. So that's the zero order. Where's this duster? So that's the zero order. Now for the first order, for the first order reaction, we are still going to solve questions involving calculations and this. So for the first order reaction, for the first order we have lane AT equals to minus KT plus lane A naught, where this is the lane of the concentration at a particular time t. This is the rate constant. This is the lane of the concept of the initial concentration. So this is the formula of which you can also liken to the equation of a straight line, y equals to mx plus c. So lane A naught is c, the intercept, minus k is the slope, t is the on the x-axis, while lane at on the y-axis if you are to plot the graph. So that's the formula for the first order. Now second order, for the second order, we have 1 over concentration of AT equals to KT plus 1 over A naught. So there's no negative here for the second order, and there's no lane. We only have the inverse of it's just like the zero order, but the inverse, except this aspect, and this one does not have negative. So you can also liken it to the equation of a straight line, y equals to mx plus c. 1 over A naught is your intercept c, your k is your m, your t is your x, y the whole this on the y-axis. So that's that for that. Now that's everything you need to know about the formula. Now let's solve few questions on what you have done so far. So now this question on is on zero order, and there is something you need to know. For zero order, let me write all the three formulas that I wrote initially. It's very important. It's very important, and something you can be tricked by it. Now let me say the zero order, the formula is what? Concentration at time t equals to what? Minus kt plus what? Concentration, initial concentration. For the first order, we have lane of the concentration at time t equals to minus kt plus what? Lane of the what? Initial what? Concentration. All these can be, these are the linear form of integrated rate law. Like that's why we liken them to be equals to y equals to ms plus c, and the one I did earlier. So for the second order, this second order, I don't think you have been taught, but let me just add it. 1 over concentration at time t equals to kt plus what? The reciprocal of the initial concentration. Now, one thing you need to know is that for here, this concentration, you know, the unit, it will be in mole. This one to the unit will be in mole. So this one to the unit will be in mole. Now the unit here, there is no unit here. Why? Because you are taking a natural log of something. Ln of whatever it is, the whole result here will just be like a number. There is no okay, let me tell us what I'm saying. I just want to show us about this unit. Now here, if I'm to make k the surrogate of the formula, this one will be from this one, AO will come to the other side. It will become 80 conc of 80 minus what? Conc of AO, right? Equals to what? Okay, sorry. Let's take 80 to the other side. If KT comes to the other side, it's minus. It will become what? Plus, abi. It will become KT. So there's no minus again. KT will give us what? Conc of AO. Then this one will come minus what? Conc of what? 80, right? Now, this is conc. The unit is mole. The unit is mole. If you subtract them, you still get mole, abi. So if you make K the surrogate of the formula, D here will be mole over time. That's mole per second. So the unit for K here will be mole per second. Do we get? If you subtract this from the unit is still mole. Because this is conc, this is conc. If you subtract two force from each other, the unit will still be Newton. So just like this. So if you make K the surrogate of the formula, that means you divide this place by T, you have mole per second as the unit for rate constant. Now for this, that's for zero order. For zero order, the unit for the rate constant is mole per second. So if they mention zero order and you have a different unit for your rate constant, then that question is wrong. You see that you leave it, it's not a mistake, it can be a trap. So just know that. Now for first order, the unit is just per seconds. How? Now let's make this the settled formula. If this comes to the other side to become KT equals to what? Ln what? Ln AO. If this one comes to the other side minus what? Ln what? AT, right? Right. This we transform this to this. So this one becomes KT equals to what? Ln. Now if you have ln A minus ln B, same thing as ln A over B. This one give us what? AO over what? AT. Now, whatever you have here, because it's inside the logarithmic function, ln of whatever it's here, whether it has unit or not, the whole answer will not have unit because you have attached it to a logarithmic function. Just like you are saying sine, since it's inside an angle, whether it's even false that it's inside the angle, since it's already an angle, everything will take the identity of degree. So this one now, since there is no unit for logarithm, ln is natural logarithm. So ln of whatever we have, yes, even though the unit is concentration, like mole, do we get? So not mole amount in mole, I mean big M, like mole per dm cube or mole per cm cube. Since the unit is big M, mole per dm cube, since it's attached to a logarithmic function, then it won't have unit at all anymore because we are taking ln of it. Do we get? So now whatever we get here, there will not be unit. So if you are to make it the set of the formula here, then the unit for k will now be what? Per seconds alone. No, since whatever we have here doesn't have unit, so divide it by t, then you just have per seconds. For first order, for zero order, the unit for the rate constant is mole per, like that big M, not mole, not this mole. It's like this big M, which can represent mole per dm cube. So I'll just use the word mole, but you understand what I'm saying. So m per seconds for zero order. For first order, it is just per seconds. Do we get? Now for second order, you can do it yourself. But for second order is um per m per seconds for second order. Please take note of those units. They are very important. Don't take them for granted. Now let's quickly solve this question. A zero order reaction has rate constant of this. So our K equals to 0.02 mole m per second. And initial conc of is 0.75 m. Initial conc, that's A naught, right? Equals to 0.75 what m. Calculate the conc after 25 seconds. T equals to what? 25 what? Seconds. Now, what's the formula for zero order? Don't mix formulas together. The question is talking about zero order. Even though if the question does not mention zero order, you can see the unit of your rate constant. That's another thing you need to know. Please take note of that. So here we have, looking at the unit, I'm not even looking whether it's zero order, but looking at the unit, mole per second, big M per second. No, mole is actually different. This capital letter M represents mole per DMQ. But don't worry. So the formula for the initial for zero order is AT conc of a concentration at a time T equals to minus KT plus what? Concentration, the initial concentration, right? So yeah, now what are we asked to find? Calculate the conk after. So we are looking for the conk at a particular time t after 25 seconds at a particular time. So the formula directly is just what we are looking for. Do we get that? So equals to minus this is what we are looking for. K, what's our K? 0.02. What's our time? 25. Plus what's our initial condition? 0.75. So are we there? So now it's 0.02 times 25, 0.02 times 25, that's 0.5. So this one give us minus 0.5 plus 0.75. So what do we get at the end of the day? This one give us 0.25 big M. This unit represents concentration. So that's that for that. Now for the second question. So this is another question. A first order reaction took 500 seconds for it to decrease to 25% of its initial value. What is the rate constant for the reaction? Now, our time equals to 500 seconds. Um, it it took 500 seconds for it to decrease to 25% of its initial value. So the initial concentration, let's assume that it is 1, or you can also represent it with 100%. Whether 1. So if you want to write the 25% of 1, now you said 25 over 100 times 1, it gives you 1 over 4. So see that you write 100% and you leave 25% for your 80, or you write 1 and you write 1 over 4 for your 80. Either way, you still get your answer. So okay, let's just use 100%. So like this is the initial conk, like nothing has happened. Do we get no decomposition yet? This is the initial concentration. 100% now. The first order reaction took 500 seconds for it to decrease to 25% of its initial. Now that means A at a particular time t. Now listen, what we need here now is how can I put it now? Sorry guys. What we need here is the conk at a particular time t. The conk at a particular time t is that part that is yet to be used. In a sense, now the thing decreased to 25% of its initial value. This 25% is no longer conk. It has been removed. The initial concentration is 100. So when the reaction took place, it decreases to 25% of this. That is, we still have now this is just it. How to find that conk at a particular time? It is going to be 100, the initial one, minus the one it decreased to. 100 minus 25, which is what? 75%. Which is 75%. Oh, sorry, it's not this. Sorry. That's a mix up. This is just 25%. Yeah. That's a mix up, don't mind me. A first order reaction took, now let's understand the question very well. So a first order reaction took 500 seconds for it to decrease to 25% of its initial value. Now this is it. Initial value is 100%. At a time 500 seconds, this concentration already decreased. So the concentration at a particular time is 25%. Just get it right. There's no confusion there. Sorry for the initial. Let me repeat again. Let me repeat myself. If S order reaction took 500 seconds for it to decrease to 25% of its initial value. Is that we use 1 here and 1 over 4 here? We use 100 here, you use 25 here. Sorry for the initial. When I get to the one we do something like that I did earlier, then I will refer back to this and show you the differences. There's actually different. The difference are obvious. Sorry about that. So this is the initial condition, initial concentration. Now at a particular time t, this 100% is already reduced to 25% according to the question. Decreased to 25% of the initial. Do we get? So at a particular time t, we already have this 100 to have reduced to 25. So what is the rate constant from the reaction? So this is just what we want to do there. So here we have conc of our at, equals to minus kt plus what, a naught, right? So what's our at? Our at is 25 equals to minus kt, 500 seconds. That's 500k plus what, 100, isn't it? Oh, we are told that first order lane, yeah, that's lane a naught. Don't mix the formula together. The initial formula I use is for zero order. So this is first order. Please take note of that. So first order equation is this lane. So we have lane 25, this lane 100. So you have to be careful during your exam, please. So yeah, if you bring this 500k to the other side, it becomes positive. 500k equals to what, lane 100. If this one comes, become minus what, lane 25, isn't it? So this one here we have 500k equals, if you have lane a minus lane b, same thing as lane a over b, 100 over what, 25, right? So here we have 500k equals to what, lane 4. 100 over 25 is 4. So k equals to lane 4 over what, 500. K equals to lane 4 over 500. Now what's lane 4? Lane 4. Lane 4 equals to 1.3863. So we have k equals to 1.3863 over 500 divided by 500. So our rate constant equals to 2.773 times 10 raised power minus 3 per seconds, not mole per seconds now. This is just per seconds. Now, this and that trick there. In your option, you can see m per second. I'm mentioning mole. Mole is different from that big M. This small m is stand for number of amount in mole, but big M is mole per dmq. Take note of that. So if you hear me mentioning mole, I mean mole per dmq because I use just big M. So now, if in your option you have something like this, for rate constant unit for first order is wrong, is per second, and I've explained it earlier in the video. This unit for rate constant is for zero order. This one is for first order. The one for second order is per m per s. And this m is same thing as small m per dm cube. This capital big M is equivalent to small m per dm cube. It can also be m per centimeter cube, small m per centimeter cube. So take note of that. Now the next question. So this is the next question that seems to be mixed up with the one we just finished. Now a first order reaction is 50% complete in 30 seconds. So our time is 30 seconds. Now our concentration at a particular time t. Now concentration is equivalent to, and that's the mix up I made earlier. So listen now. That one we grab the one we just finished. Now for this one, concentration is equivalent to um the first one is decreased to 25%. Is that 25% that has not been used. So that one is still equal to the conc at a particular time t. So that 25% is what we should use earlier. That was correct, what we did. Now this one now, the amount of the incomplete now, the amount of the incomplete part is equivalent to concentration. So now a first order reaction is 50% complete. If it is 50% complete, that means there is a 50% that is incomplete. So that incomplete is equivalent to conc, to concentration that we should have. So now our concentration at a particular time t will give us 100% minus 50%. Like the initial concentration, which must be 100%, minus the complete 50% to give us incomplete 50%. So that incomplete is our concentration at a particular time t. Assuming this is 30% complete, it will be 100 minus 30. So our concentration at a particular time t will now be 70. If it is 30% complete, then we have 70 incomplete. That incomplete is equal to our concentration at a particular time t. So which is what? 50%. So our concentration at a particular time t is 50%. So what is our initial concentration? 100%. We are not given the value. but it's 100% because at that time nothing has happened. So how long will it take for the reaction to be 75% complete? Let's leave that for now. Let's leave that for now. So what before we can get that question, the question we are asked, we need to first of all find the rate constant. So this is the first order. The formula for first order is ln AT equals to what? Minus KT plus what? Ln what? Ln A naught is concentration at a time t, rate constant, time, and initial concentration. So what's our 80? 50. What's our A naught? 100. So this one give us ln 50 equals to minus our time is 30 seconds. 30k plus ln what? Ln 100. So here we have 30k. If it comes to the other side, become positive equals to what? Ln 100 minus what? Ln what? Ln 50, right? So here we have 30k equals to what? Ln A minus ln B is ln A over B. 100 over what? 50. So k equals to ln 100 over 50, that's ln 2 divided by what? 30, isn't it? So I think ln 2 should be 0.693 divided by 30, divided by 30, that is 0.023. So our k equals to this 0.693 divided by 30 equals to 0. 0.023. This first order, that will be what? Per second, not m per second. Let me write it here. K equals to 0.023 per second, which is something as 2.3 times 10 raised power minus 2 per second. Please take note of that. Per second for first order. For zero order, m per second. For second order, per m per second. That's this duster. So now this is not yet what the question is asking us to do. The question says, how long will it take for the reaction to be 75% incomplete? No, this rate constant. This one is always constant. Whether whatever is happening, this is constant. Whether the time is whether the time varies, this is constant. Whether mole varies, this one is constant. So since it's called rate constant, we still leave it that way, not touched. 2.3 times 10 raised power minus 2 per second. So what's our initial condition? Initial concentration rather is still 100%. So we asked to find time when it is 75% complete. So if it is 75% complete, that means it will be 25% incomplete. 100 minus 75. So we have 25% incomplete. That incomplete is equivalent to the concentration at a particular time t. So since this is first order, sorry boss, abeg. So here we have ln AT equals to minus KT plus what? Ln what? Ln A naught, right? So here we have KT equals to, since we have our, if this comes to the other side, become positive. Since we have our K is 2.3, which is now 0.023 T equals to ln, this 100, right? Ln 100 minus ln 25, ln 25. So this one give us 0.023t equals to, that's ln 100 over 25. Ln A minus ln B is ln A over B. So this will give us ln 4, right? So here we have t equals to ln 4 over what? 0.023. So ln 4 over 0.023, ln 4 divided by 0.023. So that's 60 equals to 60.27 seconds. So at time 60.27 seconds, it will be 75% complete, which means it will be, the conk at that time will be 25%. That is 25% incomplete. Now let's solve the second to the last question before we call it off. So now before I solve this question, I will refer back to second to the last one I did, that they said decrease to 25% of its initial value. So that 80 there is equivalent to 25%. It's different from the one we just finished, complete, incomplete. Please get the difference. So here now we have the rate constant for a first order reaction at time t is, so our k equals to 2 times 10 solution, 2 times 10 raised power minus 1 per second. If the initial conc is, that's our initial concentration, equals to 3 times 10 raised power minus 3. 3.0 is 3. So what is the conc after 3 half-life? So we need this, right? Unknown, the concentration at the particular time t. And what's our time? Our time is 3 half-life. 3 half-life. This is the time that we are given, 3 half-life. So because this first order, and even the unit of the rate constant will make me to know that that's actually first order. Please, those units, they are trapped. Take note, please. So here we have lane AT equals to minus KT plus what? Lane what? A naught. Are we together? So now, what are we asked to? So we need to find our T. Okay, let's write it first. Lane, are we given? Now here we have lane. Okay. Um, okay. Lane AT equals to um minus minus 2 times 10 raised power minus 1 T. Now our T is 3 half life plus lane. What's our A naught? 3 times 10 raised power minus 3, right? Yeah, we are given A naught. What we are given is not lane A naught altogether. We are given A naught is the initial concentration, initial conc, that is this. And the formula is lane of the initial conc. Take note of that. So we are asked to find the conc, this 80, not lane of the 80. It's lane 80 the gangan that we are looking for. So now let's find our T first. Now half-life equals to 0.693 over k, and what's our k? 2 times 10 raised power minus 1. That's the formula for half-life. Do you get? In normal physics that we know, we say over lambda. This is like a lambda there now. 0.693 over lambda, 0.693 over k. So over your rate constant. So here now we have 2 times 10 raised to power minus 1. That's 0.2. So 0.693 divided by 0.2. That's 3 point. So our half-life is 3.465. If you divide this, you get 3.465. So since our T equals to 3 half-life, so it's going to give us 3 times 3.465 times 3. So our time is what? 10 point. So our time, if you multiply it, our time now, 3 half-life, 3 times this, we have 10.4, 10.4 seconds. 10.4 seconds. So that's our half-life. So now here now we are going to have lane 80 equals to 10.4 times this times 2 times 10 raised power minus 1. 10.4 times 2 times 10 raised power minus 1. That gives us 2.08. So here we have minus 2.08. This times we've looked for our time plus what? Lane 3 times 10 raised power minus 3. Lane of this, let's type it in our calculator. 3 times 10 raised power minus 3. Lane of the answer. So that's negative 5.81. So here we have let me clean all this part so that we can have more space. So here we have lane 80 equals to minus this. So minus 2.08 minus 5.81 minus 2.08 minus 5.81. That gives us minus 7.89. So here we have minus 7.89. So how do we find 80 now? Here we have lane 80 equals to this. So you take exponent of both sides. In mathematics, if you have e raised power lane x is equal to x, it's just like this lane we cancel e. They are like opposite to each other, something like that. It's just like you are saying y plus minus y. So they cancel. That's what happened to e and lane. It will remain x. So how do we have 80 here? Is by saying e raised power lane 80. Since you say e raised power this side, you must also say e raised power this side so that we not alter the structure, the question. So since you are taking exponent of both sides, then we have not done anything bad. Since what you apply here, we also apply it here. So this side, since this will go, like I said earlier, that's not the way it counts. So, but me, I'm just, but it goes. You have 80 left. So here we are taking exponent of this. So that's if you in your calculator, how do you press E? That's shift lane or arc lane, whatever. So shift, this shift and this lane. Shift lane can use it to turn to E. Here you have shift lane. That's you can see E raised to power minus 7.89. So I'm coming. It's showing error here. This is how we are going to do it then. Equals to 1 over E raised power 7.89. Maybe it's this type of calculator. You know, if you take it up, it will become negative. So let's do it this way. I think this calculator can manage this one. Shift lane 7.89. Okay. Sorry. We don't need to put power. That's the sorry. If you want to use this kind of calculator to press it, don't put power. Just type it directly. Don't put power. That's shift lane minus 7.89. Don't put power. If you want to type it exponent in your calculator, don't put this power, don't put it. Just say E, then after your shift lane, then you type minus 7.89. So we can see now. If you put power, whether it's positive or negative, you put power, it will bring syntax error. I don't know, maybe that's how it is for every other calculator. But for this calculator, don't put power. So here we have our conc at that time is what? At a particular time at 3 half-life is 3.7 times 10 raised power minus 4 mole per dmq, which can be represented as big M. So that's all about zero and first order. Now for second order, well, let me just for second order, let's say if k equals to 0.02 per m per s. Yeah, this is the unit for second order. And our t equals to, I just want to brief it, our t equals to 10 seconds, and we are our initial condition equals to 0.5 mole per dm cube, and we asked to find initial concentration rather, and we asked to find the concentration at a particular time t. So for second order, you know, it's 1 over this equals to kt. That one is positive, there's no negative there, plus what, 1 over this. That's the formula. Right now here we are 1 over this 80 equals to, what's our k, 0.02, what's our t, times 10 equals to 1 over, what's our initial concentration, sorry, plus 1 over 0.5. Do we get? Just input. It's not, there's no big deal there. 1 over 80 equals to 0.02 times 10, that's 0.2, plus 1 divided by 0.5, that's 2, right? So here we are 1 over 80 equals 0.2 plus 2, that's 2.2. So how do we find 80? Cross multiply. So here we have 1 equals to what? 2.2 multiplied by 80, right? So make 80 the set of the formula. That means 80 equals to 1 over what? 2.2 equals to what? 1 divided by 2.2. So equals to 0.4545. So even though if you are given a second order question, but they are not going to, I mean, for 100 level, for level 1, they are not going to, but I just brief it even though you come across it. So thanks, that's the end of the video. Don't forget to like and subscribe, and drop your comment in the comment section. See you in the next video.